welcome back. So this is 4.4 part 2, where we now talk about cosine and also two of the more basic transformations that can happen to these graphs. Those two transformations are going to be a vertical stretch or compression. So this is to do with amplitude, and also a vertical shift. So a little recap for these graphs. They're called sinusoidal, but we could call them trigonometric graphs, where you have sine and cosine. And these graphs look like these curves, these infinitely repeating curves. Because circles, as we rotate through it, we cycle through it, it does repeat. So I'd like you guys to do cosine, and your graph should look something like this. And let's actually draw a unit circle, or a circle, and see what we're talking about. So in our unit circle, my x value corresponds with cosine of theta. My y value was sine, my x value is cosine. So as we trace along the x value, we start over here at 0, and my x value, this way is positive, this way is negative. I start at a positive 1, my positive max. Then as I curve around it, at pi over 2, which is up here, I'm at 0. My x direction is 0. I keep on going around, I'm at negative 1, back to 0, back to positive 1. Then back to 0, negative 1, 0, positive 1. So this graph actually also continues on forever. And it also works as well if I go backwards. I go from 0 down to, I go from 1 down to 0 to negative 1. 1 down to 0 to negative 1. It just repeats as a cycle. So check your points. This should be a cosine graph. And similar to the sine graph, let's actually label what we have. A little refresher, amplitude is how far above or below the midline you go. So what you do is actually get the max, get the minimum, and divide by 2. Because the midpoint must be in between it. So I'm just going to divide it by 2. So 1 to negative 1, there's a whole distance of 2. Divide that by 2, I get 1. And that makes sense because my middle is at 0. I'm going up 1 and down to negative 1. My amplitude is 1. My period is how long is one full cycle. One full cycle is one full rotation around a circle, which is 2 pi. Now let's look at amplitude and this type of transformation. So we're actually going to talk about vertical compressions and stretches. So a quick little recap back in unit 2. We learned that f of x, we have this function and we're just adjusting it. To do a vertical compression or stretch on this, what you would do is you multiply this entire thing by a value. I'm going to call this a. I multiply the entire function by a value, and then that controls how big like how vertical compressed or vertically stretched we are. It's the same thing for trig functions. So I'm going to call it like this, f of theta. And I'm going to write trig of theta. Because trig, I read it like trig because it could be sine or cosine. What we're doing is we're doing a times trig. And that a is my amplitude. Amplitude equals a, or more specifically absolute value of a. Because you could have negatives, and you can't really have a negative amplitude because like you're saying a set distance. My amplitude is absolute value of a. So what I ever multiply the trig by. Let's see this in action. And also, I might even pull up some Desmos graphs to show us. Actually, look at Desmos first. So I have Desmos right here. Let's make it f of theta equals f of theta equals a times sine of theta. And we want to add a little slider for A. And here's my graph. We'll label some key points. Actually, the key points probably won't stick as we go. I'll just click them and we can see, just like with our other graph, it is nice and straightforward. We have 0 to 1 to 0 to -1 to 0. That is our sine graph. Yeah, this is similar to what we had before with our regular sine graph right here. We go from 0 to 1 to 0 to -1 to 0. So you see right now, with the amplitude of 1, it is perfectly aligned. Now when we change it, when we slowly increase it to 2, everything was stretched up to. And talking about amplitude, amplitude is how far above or below the midline you go. So it's a maximum increase and maximum decrease. I'm still starting at 0 because we're just multiplying every single y value by 0. 0 times 2 is still just 0. But instead, as I go up, I go all the way up to 2. I go down to 0, down to -2, 0, +2, 0, -2, 0, +2, 0, -2. So that's how amplitude changes my graph. So let's graph this together. Let's pick a value. We'll do a cosine one together. So now an f of theta is equal to 3 cosine theta. As we graph, I want us to get into good practice of labeling everything. We'll label more as we go along. But to start off with, I want to have my amplitude, which is my A value. Amplitude is 3. Next up is my period. Period, nothing's been changing so far. We haven't learned anything else the way that we transform it. So we still keep it as 2 pi, 1 for rotation, because my theta just goes all the way around 1 for rotation. And in a little bit, we'll talk about some more steps. But I have this. I'm going to draw my graph. And I'm going to reference, hopefully you have it in your notes, but I'm going to reference what I have up here. So you see, I start at 0, 1. But instead of starting at 0, 1, I actually want to go up, multiply that by 3. So I'm going to start up here at 0, 3 instead. Next up, my next value at 9 degrees, or pi over 2, is over here. I'm going back down to 0. Pi over 2, 0. Then we should go into the negatives. So -3, pi, -3, back up, 3 pi over 2, 0, and finally all the way back up to 2 pi, 3. If you see this graph, what it did is it just stretched up and multiplied all my y values by 3. I stretched it up and I stretched it down. I stretched this up, stretched this down. And I want us to get used to hand drawing our graphs so that we could be free to draw it however we want. When we are given axes, when we're given measurements, it might be very easy for us to just fall into that crutch and want to use it. But it won't always be really helpful for us because we're dealing with pi, and pi is not a clean number. We see right here, this point is pi 0, and pi is 3.14. Like we zoom in, it's not with a 3, it's just randomly there. If I go a point next to it, see, I just have decimals. And let's check to see if my points are true. Change to the cosine, change A to 3. We see I start at 3, go down to 0, -3, 0, +3. I have my 5 points, I have my graph, my curve, and I'm happy. My 5 points, my curve, and I'm happy. Alright, so I actually want to fall back and touch on my method of graphing. So as I said before, it is really nice to have these. And these are important because of something called, that I like to call the y step and the x step. The y step and the x step are what I call kind of how much you're changing. You're changing your y and you're changing your x every single step. Every single step, like point forward, because we had these 5 key points. Every next point should only be changed by these intervals. The y should only change by the y step, and the x should only change by the x step. Now going to this, the y step is nice and easy. Y step is actually the amplitude. And we'll see this graph example. I should only change by my amplitude every single step. And I have to change by my amplitude every single step. My amplitude here is 3, so my y step is 3. I'm going from positive 3 to 0. That was a change of negative 3. From 0 to negative 3. That was also a change of negative 3. From negative 3 to 0, that's a change of plus 3. From 0 to positive 3, that's a change of plus 3. So what happened here was every single y, like sequential y value, was changed by my y step. No more, no less, either positive or negative. This will always be the case if we follow these 5-point rule. Next up is x step. This is a bit more different because I'm not changing by my period. My period relates to my distance at x. But the period is my total distance of one cycle. And I mentioned before, what we do with this period, why we want these 5 points, is because we want to cut kind of our repeating pattern like this. We're going to cut it, take a little segment of one full cycle, and we're going to cut it into 4 even pieces, just like this. As a result, my whole period, is being cut into 4 pieces, 4 even pieces. So every sequential thing is plus my period over 4. From here to here is plus my period over 4. From here to here, plus my period over 4. So my x step is actually my period over 4. In this case, we'll have 2 pi divided by 4, which is pi over 2. And x step actually only goes forward. You can go backwards with it and then trace along backwards, but most of the time we'll be going forwards. So I want to make sure everything is being added or subtracted by pi over 2. So we see over here, 0 to 2, pi over 2, that's plus pi over 2. Pi over 2 to pi, that is a plus pi over 2. Pi to 3 pi over 2, that is once again a plus pi over 2. 3 pi over 2 to 2 pi, that is finally one more pi, plus pi over 2. Now my graph is very, very messy, but I hope you can see now that x is only changing by pi over 2, and my y is only changing by 3. Every single point. It never goes from 0 to 0 or negative 3 to negative 3. It must change, and it must change by this amount. So let's use this to practice and actually learn the next little bit. So vertical shifts. So with vertical shifts, all we're doing is we're just adding on top of what we had. If you remember back with function transformations, we just added a k value. And that's the same thing that's happening here. So my function, my trig function, is like slowly increasing. So I have my a times trig of theta. What we do is we just add a k to it. You want to get your whole value, your function value, whatever your function was, and just plus k. Just add a value. Go up k amount, or just go down, like subtract k, subtract the value. And that's how vertical shifts are. You just want to add or subtract here. Let's see this in action. Back here. I have my a times cosine theta plus k. I add another slider. Let's actually bring this back down to 1. Actually, no, bring this down to 1. Bring this to 0. So once again, I have my basic graph. And your k is like, I'm just taking everything I have and just shifting it up. And what I'm going to do is actually just make one more little ghost one. So I'm just shifting it up. It was at 0, and I'm just adding it. And let's compare these points. It might get pretty busy. But we see I went from 1 to 2, from -1 to 0, and from 1 to 2, because I'm just getting my whole function, my same function, because a is still 1, and adding 1 to it. So that is what our shifts do. We just want to add 1 to everything. But it's hard to keep track of. If we're adding my y step, adding my x, and then also adding a k, that is very confusing. That is why I made up this rule of x and y steps, so that we just follow this. This is the only thing that matters once we graph one point. So to graph this, we'll do a sine function now, where f of t, we'll try t, so it's not always theta. F of t is, we'll do 2 sine theta, not theta, I just said it, we're not going to use theta all the time. 2 sine t plus, let's say you do -1. I want to shift everything down 1 unit. As always, I want to write, what's my amplitude? My amplitude is 2. What's my period? My period is unchanged, it's still 2 pi. Now I still want to write, what's my y step? My y step is my amplitude, so it's still just 2. What is my x step? My x step is my period divided by 4. So it's 2 pi divided by 4 to get pi over 2. And now finally, what shifts do I have? My shifts, I see my k is -1. So I'm going down 1 unit. Vertically shift down 1 unit. Now, we draw my little axes. And the procedure for this is actually first, you want to start with your basic point. Start with your basic point. Like plot the beginning. Plot your first parent function point. So where does sine start? We can think back to, oh, where's my y value at 0 for my unit circle? Or just kind of, as I said before, you will end up memorizing these graphs as you do it more and more. Sine starts at 0. So sine starts at 0. So we have our first point. Then we want to multiply by amplitude. My amplitude is 2. I multiply this by 2. And it's still at 0. I multiply my y value by amplitude. So it just still stays at 0. That seems redundant, but that is important for cosine. And I say multiply so that you're not adding or subtracting and actually accidentally moving it. Amplitude for the first point is useless for sine, but is important for cosine. And now finally, we want to apply shifts. Apply shifts. I'm horizontally not shifting, but I'm going down 1 unit vertically. And now that is my point, 0, -1. Once we find our first point, all we do from there is when we graph it, we just apply x and y steps. And what do we do with this is we just want to see the pattern of sine and cosine and then add or subtract x and y steps as we need to. So my sine graph, we see that sine starts at 0. It goes up, down, down, up. It curves up, then goes down to the middle, goes down to the minimum, and goes back up. We follow that same pattern, but instead of moving up a weird value, we just move up and across my x and y steps. So let's do y step first. I'm going to move up 2. So 1, 2, up to positive 1. And then I go my x step to the right, pi over 2. So my point is actually pi over 2, 1. Because that was my x step. My x changed, pi over 2 amount. My y changed 2. Now sine next actually goes down. So go back down, I subtract my y step. So 1 minus 2 is back down to negative 1. Pi over 2 plus pi over 2 is pi. So I'm over here at pi, negative 1. Then we keep on going. We keep on going down. So subtracting my y step, negative 1 minus 2 is negative 3. And pi, so negative 3. And pi plus pi over 2 is 3 pi over 2. So I'm over here at 3 pi over 2, negative 3. Finally, sine goes back up. So 3 pi over 2 plus pi over 2 is 2 pi. And negative 3 plus 2 is negative 1. We have 5 points. We have 1 full cycle. And there is my graph with all my points labeled. And take a look at this shape. I curve up, then down, then back up. That is the same exact thing as this sine graph. And we'll actually confirm the points, the coordinates, with Desmos. So we'll convert this. Actually, sine, and it was 2 sine t minus 1. We see my yellow curve, my regular sine graph is actually staying like that, but we see I'm going from here, here. Actually, I need to get a line right here. We'll just keep that there, just to see the intersection points. Negative 1 to positive 1 to negative 1 to negative 3 to negative 1. 0, pi over 2, pi, 3 pi over 2, 2 pi. So the main takeaway for this lesson is the x and y steps, and rely on that for our graphs. You want to be comfortable with x and y steps and understand that it does work. You want to trust and only move forward, up, down, across, left, right, that amount. And please, as we do more problems, the fractions will be a bit harder. Like the periods will change soon in like a lesson or two, but you want to be careful. Like if the x step is like pi over 4 and you're adding it to like 3 pi over 2, that becomes a bit more harder. So please refresh up on your fraction addition and fraction calculations. But I think that's it for this lesson. Thank you.